Okay, gents, now is the time to find out how many different types of DGNSS arrangements we have for our DP purposes. Generally, we have two main arrangements, like single reference station solution and network station solution. Let's overview the single reference station solution. So in that solution, all satellites are observed from a fixed location reference station. Reference station location is accurately known, thus accurate ranges may be calculated. The reference station also measures ranges to all satellites. The reference station compares the measured and calculated ranges. The differences calculated are the range errors. Corrections for these errors are computed, and then the GPS correction signals are transmitted to users. The user's system is able to update its position reference equipment to increase the accuracy. So the main idea is that your demodulator on board of your vessel is able to read the corrections from correction station. Now please let's find out what is the network station solution when we are discussing the DGNSS. In network station solution, an array of reference stations provides a network. Each station computes its own corrections. Corrections sent to a central hub control station, and this is the main difference from previously discussed solution. Corrections multiplexed, or in other words, corrections are compressed into a signal. After that, corrections transmitted by radio signal to the satellite system in use. Then corrections received on board, where a multi-reference solution is computed and appropriate the GPS offset selected by the GPS equipment on board. In other words, in that type of solution, we have the satellite network in use, and in that case, the distance from hub or reference station doesn't matter to the vessel which use that kind of DGNSS service. Gents, now is the time to talk about accuracy of modern DGNSS. And generally, I need to say you that the accuracy depends on the readiness to pay for the services, because we have even free of charge YALA services for marine world. When we're talking about the DGNSS, we have prepaid services, we have extremely, let's say, dedicated and accurate services, and the accuracy of your DGNSS depends on what services you are contracted to use. So let's talk about accuracies. YALA typical accuracies is about 5-10 meters, or it gives you 5-10 meters error at the distances less than 200 kilometers from the nearest land where the YALA reference station available. The GPS positioning accuracy in a pure way gives you plus minus 20 meters error if we are talking about civilian frequencies, and the military precise code can give you less than plus minus 10 meters error. The ACURACY Star Network DGPS service gives you at the distance about 500 kilometers from reference station about 1 till 3 meters error, and at the distances higher than 1000 kilometer and about 1000 kilometer it may give you 2-4 meters error and more, of course. The high frequency and medium frequency services can give you the range coverage about 400 to 800 kilometers. The Inmarsat link gives you worldwide coverage but on low power. The spot beam link, the spot beam means that the satellite covers a certain geographical area only. Can give you high power but very local coverage. The UHF range is about 40 kilometers and normally it works in line of sight. And the UHF link usually related to a temporary reference station located on a platform and where some project goes around the oil field or platform. So, conclusion, accuracy of modern DGPS mainly depends on services in use. Then I need to say you that there are some solutions which are known as dual frequency DGNSS. For example, the ACURACY Star Plus in dual frequency. Those are intended to counter effect of a localized ionospheric interference. They call it scintillation. Dual frequency reference station monitors both frequencies L1 and L2 which are related to civilian and the military code. L1 and L2 suffer different delays due to ionosphere activity, and those receivers gives you better performance and errors connected with the propagation of the radio signal in ionospheric layouts are avoided with such kind of technology. So guys, this is the time to close the discussion about idea of the DGNSS, and next what we are going to check out is the DAPS.